Professor Jonathan Rajewski, my colleague at Champlain College. It's being a Champlain College night tonight. John is going to get us. You've got to get your paper out. Move it that way. I keep thinking I'm in a mirror. And your pen. Old school, really old school stuff. Analyst notebook doesn't count. Paper and pens at the ready. We're having competitions. You need to make notes. If you're drinking, you will possibly hamper your abilities to win the great prizes. So I'm going to bow out now and hand over to John.
All right, can you hear me, everybody? Waiting for the chat. All right, good. So as Mike said, this is a hands-on type of practical exercise. Pen and paper is strongly encouraged. If you cheat, I'll be mad and sad. So please don't cheat. Use online resources because you can clearly use them. But this is really going to be a fun exercise that we're going to do here. A little bit about myself if you don't know who I am. About 5 years ago, I started teaching at Champlain, digital forensics. I'm also the co-director of the Senator Patrick Leahy Center for Digital Investigation. Up on campus, Mike Wilkinson is the other co-director. I do work with the Vermont Internet Crimes Against Children Task Force. I'm a former senior consultant. I've got a bunch of certifications. I won some award last year. And there's my Twitter, and there's my blog. Feel free to connect and leave comments there. 31 slides of lecture. We're going to move fast, though. We're going to discuss a little bit about crypto, about 5 to 8 minutes, discuss some transposition and substitution ciphers, and then the key here is to really just kind of take notes. I'm a very visual learner and a visual teacher, which makes this kind of difficult for me. But I did try to add a bunch of animation, hopefully it works, in the slides that will hopefully help. But please take notes and then ask questions whenever you have them. And then we'll have a crypto challenge, which will go on until we have a winner, or until Mike runs out of beer, one of the two. And there will be prizes. And there actually is control built in place. We can track to see who is winning these challenges. So if you do win, please send Mike or myself a note with your address, and we'll send you the prizes. And we'll make sure they'll be great. So we'll start off with something that literally, this is my phrase, just something that I came up with called the 3 C's. The 3 C's is cryptography, cryptanalysis, and cryptology, which gives you the 3 C's. These terms are also synonymous with just calling it crypto. I mean, if you have a conversation with anyone at a conference, you talk about crypto, you could be talking about any one of those things. But what is crypto? Okay, class. Someone define crypto for us. Matt, hidden writing, math, good. If we break this word down, because I like to break stuff down, take really complicated topics and try to make it really easy to understand. Cryptography, if you break this down, it literally means hidden writing. If you try to define it, it's actually pretty hard to define. RSA's website, if you look at their website, they say it's if I try to recall correctly, it's creating something difficult to break, and there's a lot involved. I mean, from our perspective, when we have something called plain text, which is what we see here, DFIR online is fun, wow, and then you pump that through some type of crypto system using some type of algorithm. And for algorithm, I think it was Tone Surfer said math. Yeah, it's math. Some type of math is happening, and you get the output, which is ciphertext. And this, of course, is called the encryption process. What is cryptanalysis? Come on, who's going to get it first? No prize, but come on. Type faster. Press enter. Multiple breaking codes. Good job. So cryptanalysis, break this down. Crypto and analysis, keep going. Cryptos, some of you may know what Cryptos is. My first slide, by the way, was a rendition of Cryptos, which is the sculpture in front of a 3-letter government agency in Washington, D.C. If you want to know about Cryptos, Google it. It's really cool. And you can get one. You can get one from the National Spy Museum for like $100 or something. But it's the most nerdiest thing you could ever have in your desk, and people will love you for it. Hidden and loosened. So that's cryptanalysis. Cryptanalysis is essentially the methodology or process of decryption. So we take that ciphertext, pump it back through the algorithm using usually a key and you come out with the plain text. Voila, that's decryption. Cryptology, break this down. Cryptos, logos, and the hidden topic of study. Keep moving here. Cryptology is the study of cryptography and cryptanalysis. So let's do our first math problem. Cryptography plus cryptanalysis equals what? Go. Type answer, please, quickly. Yes, very good, Bill. Yay, cryptology. None of my students, oh, there's one of my students, he got it, because we did this today in class. Good job. And this is, so now we're going to start fast forwarding into like basic crypto systems. But of course, you cannot teach crypto without showing this, this comic. And of course, this has to do with cryptanalysis. But, you know, the gentleman on the left, it's the imagination of the crypto nerds. We're going to build this sophisticated, highly expensive $1 million cluster to break encryption. And they find out that the encryption is really, really strong encryption, so they can't break it, and in a reasonable amount of time. And what would actually happen, of course, is the joke, that his laptop is encrypted. We're going to drug him and hit him with a $5 wrench until he tells us the password, which is, you know, probably a faster way of getting what you want. It's not an ethical way, but it's a faster way. Basic crypto systems, codes. I mean, a code is something like, let's say if I start speaking Polish in the mic here, people won't really understand it. But essentially a code is just encoding words or phrases. Some examples is Morse code or colored flags on naval ships. Morse code is this. Most people have heard it or seen it or at least read about it somewhere. It's a series of dots and dashes, right? And if I were to just say dot, 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 dash, 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 dot, 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 what do we have? SOS. Good job. Yeah. So Morse code, you know, it's used a lot. It's still used today. Most Navy people that you talk to, any former Navy vets in the room, you definitely know what this is. Maybe people in the military, I'm not from the military, but you probably do as well. But essentially what you're looking at here is a submarine at periscope depth. They're communicating via pulses of light going across the sea, which works. Oh, went the wrong way. So drawbacks to using codes in its own plain form is a long message could be a problem. If you're trying to transmit a long message via Morse code, you make a mistake or the receiver doesn't see it or they misheard something and they write something wrong, they have a big problem. And also, let's say you're trying to send a code via Morse code, like you have a different word that means something else to somebody. You typically need a book called a code book to keep all that straight. Now here's the problem with code books. And I'll just talk about baseball, and of course I'll talk about the New York Yankees because they're the best team on the planet. The pitcher and the catcher, they're always communicating. And the catcher, if you ever watch baseball or softball, the catcher is sending codes back to the pitcher, and they agree on a pitch, and the pitcher throws the ball. The problem is networks, you know, with your friends, or you know, if you're talking in code at a conference. The codebook issues here is, let's say you start increasing the amount of people you have to share the codebook with, or the passwords. You need some type of key distribution mechanism that will keep it safe. So let's say if one of your free agents leaves the team, they can't steal all your codes. You don't need to, somehow you got to figure out how to revoke the code book from them, and also a way to maybe change all of your how to steal a base code. Yeah. So codebooks have some issues. Basic ciphers. We're going to talk today mostly about substitution ciphers, which is replacing one character with another, and transposition, which is just kind of rearranging them. You can disagree with me, Don. That's okay. Substitution ciphers. So the most famous one that most people know is the Caesar shift, or the Caesar cipher, which essentially just kind of shifts the alphabet over by 3. It probably wasn't Julius Caesar who came up with this. It was probably one of his mathematicians. But what we see today is similar to the Caesar shift is row 13, which is essentially, there's my arrow. You've got your plain text alphabet, A through Z, and below that is the cipher alphabet. So you go 13 characters over, you just go to my red arrow, you'll see starting at 14, you start with A, and you start wrapping around. So if you want to encrypt something, which we're going to do in the next slide, you just use your cipher alphabet when you generate your ciphertext, and that becomes encrypted. You can also substitute letters for symbols as well. So where are we seeing this? I mean, this shouldn't be news for anyone in the room. We all know about the user assist key. For those that don't know what the user assist key, it's essentially that left side of the screen where you press start in Windows, and it keeps track of the most recently, most frequently, and pretty much any executable that you run within Windows if that registry key is enabled. And that key itself is encrypted with Rote13. Most tools and before I get there, actually, we're seeing it in the Windows registry, which I just showed you. I also was doing some research today, just kind of figure out like where else are we seeing it, and there's a bunch of references, and I couldn't find one to the specific malware that does it. But there's a lot of people saying that, well, you know, malware will use Rote13 to exfiltrate data before it'll actually exfiltrate data. It's very, very common to see the XOR function, which most people in the room, if you've ever done any malware analysis, it'll use XOR, but Rote13 can be used to obscure the data so it could maybe transfer across the network without a proxy seeing it. It won't be in plain text, essentially. Again, tools to process Rote13. If you haven't used volatility to do it, you're missing out. It's volatility, of course, most people in the room probably know what it is. Open source, great tool. As we all know, Harlan Carvey's Red Ripper tools. And also, if you're not worried about the data of what's going to be decrypted, you can use Rote13.com, which is one of my favorites, just to quickly, you know, send messages back and forth if I'm sending them to a student or something. But what if? What if Anonymous shuts down the internet, which is very, very possible? March 31st, they're scheduling an attack on all 13, quote, this is what they're saying, all 13 DNS servers, the root DNS servers. But don't worry, Miko's coming to the rescue, because today he tweeted that, you know, for your information, there are not 13 root servers, there's a lot more. But let's just say you don't have the ability to download, you know, the volatility tool, or you can't get a hold of Harlan scripts. You've got a problem. We have to do this by hand, which is going to be fun. So let's do this by hand. Ciphertext. Here it is. Break it. While I sip my tea. Good. Most people in the room got it quick. Now, just to kind of show, because I love, again, you know, I want to make sure that everyone in the room is getting this, because this is a pretty simple cipher. I mean, it's not doing anything crazy here. The plain text is Apple, but how do we get there? So if you take, the ciphertext is what you're actually going to transmit to someone, because you don't want the person in the middle to see the communication. They're going to see it, but they might not. You're hoping that they don't understand it. So the N in the cipher alphabet matches up to A. The C to P, the second C to P, and then Y matches up to L, and R matches up to E. Any questions? Excellent. Moving on. So, we're not going to focus on this, but frequency analysis is kind of cool. If you have, if someone's using like a single alphabet substitution cipher like Rote13, you can look at the most frequently used letters, digraphs, and trigraphs. So the most commonly used letter in the English language is E. And any other book about cryptanalysis, and there's many of them out there, will talk about different languages and what's the most common, you know, letters, digraphs, and trigraphs, what they are. But if you only have like a string of text and you don't know what it is, you could try to just do frequency analysis on it, and based on the statistics, you should be able to tell or make some type of educated decision as to what that ciphertext is. Now, if they're using multiple alphabets, which we're going to talk about in a second, it gets those techniques will defeat using frequency analysis. So we'll talk about Pigpen Cipher. This is also known as the Freemason cipher, which is basically going to substitute symbols for letters, and it's all based on a grid. So on the left, I should have did some highlighting here, but you'll see the English alphabet. A, B, C, D, E, F, G, H, I is on the left, and J, K, L through R is on the right, top right, and then you see S, T, U, V, bottom left, then W, X, Y, Z. Now, those symbols, so if I draw your attention to the A is, the symbol is, it looks like a backwards L, and if you actually look to the right, the plain text that we're going to encrypt is Apple computers. The ciphertext using the Pigpen Cipher is, see the A? It's the same symbol. And then P, and it keeps moving on and on and on. Are we having issues seeing the video? Okay. So, yeah, so does anyone have questions about this? Because we're about to do an exercise. We're going to see who can get it. So, if you don't get it, I'm going to guarantee you're going to get it after this. So I'm betting that some people in the room have read Dan Brown. I've read this book. It's really good. But if you look at the back of it, and it's funny because when you know to look for these types of symbols, you'll see them all over the place, and you may now be able to decrypt them. So actually, let me point them out. There's a cipher on the back of this book. So if you have this book on your shelf, go find it, and you'll look at the back, and you'll see that there's some cipher on the back. Let's decrypt this really quick. So can you see my mouse? If you can't see it, but you should see the 2 rows of ciphertext. Now, those in my class don't give away the answer because we did this today. But you should see a series of 3 words on top, and there are 1, 2, 3 words on the bottom. So give it a shot. It should take roughly a couple of minutes. First person to get it, just post it in the text. Any Buffalo Bills fans in the room? Maybe. It's kind of embarrassing. Oh, Dave got the first top. All great truths. So did Richard. Good. And those working on it, even though David and Richard were first to the starting line and they finished first, you should have been on the same track. And if you're not getting all great truths, that means you're doing something wrong, and you want to ask a question so we can help you out. This will all be on the quiz. The last word is a little non-standard. We got it. So those that are still working on it, continue working. Don't look at, keep working. I'll give you a second. Nice. And here is the answer. All great truths begin as blasphemies. And if you read the book, this has context of the book. I'm not going to talk about it, but it's kind of neat. It's actually Kevin Mitnick's book, Goes Down the Wire. It's sitting on my desk. I still haven't read it. It's in the queue. I got to read Harlan's Windows Forensic Analysis 3 first, but I guess that book has a bunch of ciphers in it, and I believe one is a Pigpen. I know one for sure is the next cipher we're going to talk about. The Columnar Transposition Cipher. Now, what we're doing now is we're not substituting, but we're actually going to start kind of disguising the message by rearranging the letters. So, if our plain text is DFIR online is so much fun, don't you think? I'm not from Minnesota, but let's just pretend. What we're going to do is we're going to write DFIR online is in the top line. And then the second line is going to be is so much fun, don't. And then the third line is going to be T and then ch, think. Then we have to add where you see the underline, it's the padding. So, and the reason we have the padding is it's going to make more sense because when we create the ciphertext, it's going to be, you need to make sure you have equal columns and rows here. So here's the cipher. And when you create the cipher, it's actually very simple. You just read down. So DST, so look at those 3 rows, and the first character in each row, DST, FOC, and you just keep going on and on and on. Now, it's pretty simple. If you look at the first cipher, not the cipher enhanced. The first cipher actually keeps it in the amount of rows that are there. So you see DST, FOC, IMH, RUA, so on and so forth. Now that would be kind of a good hint to the person trying to break this, because now you have maybe an idea of how many rows there are. But if someone just produced to you the cipher enhanced, which all I did was remove the spaces, it becomes far more difficult. And you could literally, maybe with you can code it, or with a spreadsheet, or with a piece of pen and paper, you can try to figure out over and over and over again what's the potential plain text based on the ciphertext you're looking at. So let's break this thing. And there's mathematical ways to attack this, but I didn't want to make this I'm not a mathematician, full disclosure. But for all intents and purposes, and I'm just reading the slide here, cryptanalysis by hand in a quick time frame, we are going to attempt to guess how many rows and columns are there. If you want the challenge, take the cipher enhanced method. If you don't want the challenge and you just want to do it, use the cipher there. Use the data I have there, and bring your pens and papers out, and let's see if we can break this. Good. People are putting in. I'm not going to say it because I don't think people are looking up yet. Don't look to the right. Excellent. So the answer is, did you get it? So I didn't actually write this out, but all you have to do is write down DYGI, and then the second row IOUT, and then you're going to read down after that, and you'll be able to get the answers. So moving on to something a little different. What we see here is something new, which is multiple alphabets, which could get a little complicated. How many alphabets are there? Come on, Rox. Don't count them. You should just know by looking at it. Yes, 26. So what we're doing here is we are going to use multiple alphabets to encrypt the string DFIR is great. And don't pay attention to the top side intersect yet. So the plain text message that I want to send to my friend to be super secretive is DFIR is great. And then a key that we're going to use is the awesome file system, NTFS. And we're just going to repeat that, because that's going to be our key between the friend I'm sending this to. And they know what the key is. So it's NTFS, and you just repeat that through the duration of the plain text. Now, to encrypt this thing, you use the plain text plus the key to get the ciphertext. So let me have my arrows. Hang on. This took a while to animate. Hopefully it works. So the D, this slide is wrong. Where it says top and side, this should be reversed. My mistake. You find the D on the side, and you find the N on the top. Then you find the intersection, Q. Then the next one. Wow, this animation is working. Find the F on the left. Find the T on the top. Find the intersection, you get Y. I'm not going to do any more animations, but you get the point, right? So that's your ciphertext. Now you can send that ciphertext, and it's a little tricky now to break it, or for your person to reverse it, but let's try that. So the ciphertext, remember in the last slide, actually I'll go back. The ciphertext was what the intersection was, which is Y in this example. So keep that in mind. Now we're going to use the key here, fat, the other file system that we all love. So go to the side with the key, which is fat. Find the F, and then find the S at the intersect, and start to decode this message. Questions? Yep, David brought up the Navajo talkers, yep, which was used in World War II by the U.S. to communicate. That's very true. Nick got it. I'm not going to give it away yet, but keep going. See if you can get this. It's also a nerd reference, of course. We have to do that. We have to keep you guys engaged. Don't go cross-eyed. This is fun stuff. I mean, honestly, for those that are like, having fun with this, it is a lot of fun. It's a lot of puzzle work. There's some amazing books out there that if you're interested, just send me an email. I'll send you a list of, they're like introductory all the way up through advanced stuff. I don't do any of the crazy advanced stuff, but definitely there's amazing historical books out there. The Code Breaker is one of the best books, but the problem is it's about 1,000 pages. The answer is anyone, I'll let you guys keep working on it for about 30 more seconds. Nick is a rock star. So the answer is NTFS MFT entry. And to get that, all you have to do is, and I'm kind of giving you the hints on the side, except for the last slide I screwed up. But the intersect, you find the side, find the intersect, and then bring it back up to the top, and you eventually walk through the NTFS MFT entry to get the answer. So we'll continue on here just to keep things going. So why is this cipher interesting? Well, if you're following, if you follow, I'm going to screw up his name, I apologize, Dieter Stevens, great guy, amazing blog, does amazing stuff in the industry. So we all know about user assist, and Route 13 is used to encrypt user assist. Well, the Vigenère cipher was used for a short period of time when the Windows 7 beta came out, and it was basically replaced the Route 13 algorithm, which is pretty interesting. And what he did is basically he determined this. And the way I think he broke it, he didn't post how he broke it, but when you run an application, you know its name. So if you have the plain text and you can see the ciphertext, you can then try to figure out the key, basically doing the same thing we just did. There's also, I think someone mentioned on the right, I saw there's scripts that will do this for you as well. There's programs out there that'll do it as well, but it's not as fun. So, are we ready? People win prizes now. We have at least 3 prizes to hand out. I'm not sure what they are yet, but we'll make them good. Crypto Challenge. You work, and some of you probably do, you just won't admit it, for a super secret 5-letter government agency, wherever you are in the world. This is an ultra sophisticated ciphertext located on an internal server. It must have been APT. Our team of cryptographers are actively working on breaking the code, but they need your help. And if you don't do it, we're going to lose. We're going to lose. We can't lose. APT is going to win. So, phase 1. The following ciphertext was found. The cryptographers, they believe it could have something to do with the user assist key. Hint. So there is your ciphertext, and I maybe put a piece of information on there that can help you. You will know the answer and what to do with the answer when you break the ciphertext. That's all I'll say. I think someone's making progress because they said haha. I think because I see there's 43 people in here in the room right now, I'll wait for at least 5 to 10 people over the next like 4 or 5 minutes to see how far you get. to start revealing stuff. You like that? Had to make it a little more interesting. Okay. Jonathan Joe, yeah, look at that text and figure out what that text means. Yep. Why would I drop? Mike already has malware on your system. We're logging to see what people are cheating right now. I'm just kidding. We wouldn't do that. In a second, those that are having issues, I'm going to show you exactly how to do this one. And what's great about phase 1, phase 2, and phase 3 is that the results are going to be discussed and everyone's going to be able to keep moving forward. Next one will be a Pigpen Cipher, and then the last will be the Vigenère square, which is the hardest one. I don't see the results being posted yet, and the result is not what the cipher texts. Oh, so sad. The result is not what the cipher text directly says. Oh, Jonathan Joe, don't give it away. All right, so I'm going to move forward just to keep the ball moving here. There you go. Forensic Rockstar, that's right. So, to get to the answer, did you get it? It obviously was using row 13 encryption. The ciphertext is the first line there. The plain text, if you do the substitution, I mean, if you go back to this slide and you do the substitution, looking at the ciphertext, which is the last row there, or the cipher alphabet, I should say, take all of those ciphertext characters and match up the plain text. If you wrote that thing out, it looked just like the PT, colon, the bit.ly/A0PV8D. Now, I just want on the side here, the last sequence of characters, you can't row 13 numbers. It doesn't work. It's not a part of its function. So that may have given it away. I didn't want to put dots or slashes in there as well, because that would have also given it away. You would have known that was a URL because you would have saw the sequence of characters, which would you guys are all smart people. You would have figured that out. So I put the words dot and slash in just to obscure it a little more, which is a link bit.ly/A0PV8D, which will get you to the link, which I think a couple people got to it. So congratulations. You can go to that link. It is a pastebin site. It will not infect you. It just sends you instructions about what to put into the chat screen to prove that you got it. So, Mike, hopefully you're checking to see who got it first, because I wasn't watching. But whoever got it first, send Mike or me an email, and we'll get you a prize. Phase 2, are you ready? We just learned that some of the code on the pastebin.com website indicated that there might be a hidden key for the final aspects of the cryptanalysis. Visit that link to decode the data. Good luck. Dum, 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 dum. This is going to be the Pigpen Cipher. Yeah, I put it up on the screen too to help you. Sorry, my bad. I forgot that was in the animations. So there is the key to use. If you didn't take notes on it, that's fine. It's all there right in front of you. You should just be able to use that. It is all alphabetic. Yes. Yeah, what we're looking for now is the key to the next cipher, which is the Vigenère square. Uh-oh. Oh no, did John break it? It's very possible. Let me minimize. Can you see my internet browser? No? Okay, let me see. Uh-oh, did John break it? He probably did.
You'll, if you stop sharing this, you can share your screen and run the stuff through it if you want. Okay. So you'll stop sharing the PowerPoint, but you'll be sharing your entire desktop. So just be aware, everyone gets to see whatever wallpaper you're using and whatever other stuff you may have.
All right, I've got the full URL here. Let me just run it through Bitly again.
Or you can just post it up in the chat.
Yeah. Copy. I love copy and paste. Sorry about that, everybody. How about that one?
There you go.
Can you see the best team in the world there? Okay, good. Just making sure. The first word is wow. I think my red pen got a little fuzzy. I think this is the most people I've ever had click a Bitly link ever. Excellent. Colleen got it. Yeah. Sorry about that. All right. So you should have seen, so like if I click stop sharing, oh wait, no, I've got the next screen. So if I go to the next screen, you'll see the code, which was the Pigpen Cipher. And if you bring up the Pigpen, and I'm just going to basically superimpose the letters in my amazing crafted text box, you see FORENSICATOR, not to be confused with a word that might sound like forensicator, but forensicator is a coined term. If you're on Twitter or any of the digital forensic incident response groups, you should know what they are. I think either Eric Huber, Rob Lee, or somebody coined it. Yeah. Oh, Keith, is the third letter wrong? Did I screw up? No, it's the R. F-O-R. Corrected is wrong. The bottom line through. Yeah, did I make a mistake? Oh, I totally screwed that up. Thank you for pointing that out. So what's happening is F-O-R, I added that third line. I added a bottom line I shouldn't have. Good catch. And there's no, that wasn't part, yes, that was part of the challenge. Good job. All right, so we got it. Forensicator, good. Moving on. Phase 3, the end is here. We've identified the final encrypted string of ciphertext by analyzing RAM using volatility. Congratulations. Yay for open source tools. We love them. Agency cryptologists believe that you will crack the case, no pun intended, and reveal the cyber villain. Please analyze the ciphertext with the key forensicator. Notice that while forensicator is our key, you will not need every character. In the next slide, we'll I'm going to try to make it easier for you. What we're looking for is the plain text, right, which is the PT. The ciphertext is there, which is, again, if you remember from the earlier slides, that's the intersect. The key is forensicator. Now notice that the length of the ciphertext starts at I, goes to Z, and then F, you only need to go to T. So the O and the R is just, you're not going to need it. So what you're going to do to solve this is take the information you have, you know the side, you know the intersect, and try to come up with plain text. Holy cow, people have it already. If you've ever taken a class from me, you might have a hint. And Nick, you've got part of it. Yep. Yeah, Nick, you definitely had it first. But Steve, second. Colby got it. Nathan's got it. Good, 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 good. So, another 30 seconds or so if you're still working on it. Don't look in the right pane because people are starting to post the answers. Again, what's really cool about this cipher is that it was actually used by Microsoft as almost like an Easter egg, which is kind of cool. I mean, you might come across some text, and if someone says it's a Vigenère cipher, now you can break it without using an online tool. So, looking at the answers now, so let's do phase 3 review. The answer is Doug the Pug, and I have a pug. His name is Doug, and typically he's the villain in most of my classes, and students just have to figure out how to prove that. But yeah, Doug the Pug, he's the guy who hacked our network with the APTs, and that is it. Again, thank you very much. If you have any questions, I'm going to start. I see a bunch of stuff on the left pane. Then I'm going to look through all the questions. Feel free to visit our websites, or Computer Forensics at Champlain, or my blog, or follow me on Twitter. I'd love to follow you back to help you out. But I'll start going through some questions, and we'll go up. There's some talks about Pigpen Ciphers, Navajo Code Talkers. Yeah, we talked about that. Difference between coding. Yeah, very, very true. When you start getting into even like DES, like digital encryption standard, you'll see that there's a bunch of transposition and permutation going on. So even the basic concepts we talked about are still used in those upper level algorithms. People are getting the answers. Computationally, do you think this cipher is greater than or less than or equal to Rot 13? I think it's definitely more sophisticated because it's using more alphabets. Yeah. Good. Well, hopefully everyone liked it.